Now this one is a good question. You can see here, whenever the question is given without the figure, it is obviously a challenge to get the figure correct. If you've got the correct figure, I believe half the job is done. So here, let's observe. A point E is taken on the side BC of a parallelogram ABCD. So first you make a parallelogram ABCD and we select a point E. Now, don't take E to be the midpoint of BC, because taking anything which is not mentioned in the question will complicate it further by hinting you towards most of the time congruency. Now supposing E were to be the midpoint, you would spend half the time thinking triangle AEB and triangle FEC are congruent, which they are not. Here you can see we have a smaller triangle here, bigger triangle here, so they are not congruent. Now again, this is area theorems, so you need to work between parallel lines. Now see here, the AE is produced and DC is produced, they meet at F. Good thing is that AB and DC are parallel, giving you a lot of scope to deal between the two parallel lines. Now we have to prove the area ADF equal to area quadrilateral ABFC. Area triangle ADF equal to area quadrilateral ABFC. Come on, they don't seem to have anything in common. They're entirely different. What is to be done? Now this is where you need to think. Now you think when I'm also thinking. This is the spot where you need to work on which part of the two shapes mentioned are common, and then there are parts which are not common, and what to do with the parts which are not common. So in the next part of the video we'll see what part is common and which parts are not, and how do we deal with them. Now as I said, in this part you need to visualize which part is common and which is not. Okay, this time I am not appearing on the screen. Common area is ACF. Can you visualize that triangle ACF? And the parts which are not common are the triangle ADC and triangle ABF. So that's the cross triangle, the triangle with the cross, and the triangle with the dots. Now, what's your task? Your task is to visualize a third triangle which will connect these two triangles. Alright? Alright, so here we told you to connect the third triangle. Get the third triangle now. Did you get it? We have ABC as the third triangle which is connecting the green dotted triangle and the triangle ABF. So ADC and ABF is being connected by that. Now, how does it? This time we are using two different types of theorems, and you'll have to state me, you'll have to work it on with me. We have triangle ADC. We start with triangle ADC and we tell triangle ADC is equal in area. Now whenever we say triangle this is equal to another triangle, they are equal in what? They are equal in area. So we are not talking about any other equality, it's just that they are equal in area. So ADC is equal in area to which triangle? It's triangle ABC. That was correct. ABC. Now, I have not given the reasons. You need to work on the reasons. What's the first reason here? Here the reason is that the diagonal of a parallelogram divides it into two triangles which are congruent and hence equal in area. So you just need to write this reason. The diagonal divides a parallelogram into two triangles which are equal in area. That's why this green triangle is equal to this red triangle. Now we start back with triangle ABC. Now ABC is equal in area to which triangle? Triangle ABF. That's right. Triangle ABF. Now this time the reason which you are mentioning will be different from the previous. This is the usual reason. They have the same base and lie between the same parallels. Now some of us feel the word base means that they should do something with the ground level. No. This is not at all essential. You have to observe things in all the directions. So here, this time the base AB is at the top. But they have the same base AB and they lie between the same parallels. So ABC is equal to ABF. Finally, once we had the triangle which was connecting these two, we got the job done. The job done was ADC, triangle ADC is equal in area to ABF, to triangle ABF. That's exactly what we have written here. ADC is equal to triangle ABF. Now we need to add something to both, because if you remember, the proof started with area of triangle ADF equal to area of quadrilateral ABFC. So the blue part and green part which was not common, we worked them that they were equal. Now we need to add the common part. The common part was this, that is the triangle ACF. Triangle ACF, once added on both the sides, this side we get ADC plus ACF, which is triangle ADF, and this side we will get ACF plus ABF, which is nothing but the quadrilateral ABFC. Alright, this gives us the proof. Of course, the reasons you can work out. First reason, triangles diagonal divides. Second reason, having the same base lying between same parallels. We get this. What's the reason for this statement? This is from 1 and 2. This is 1, this is 2, and eventually once we get this third statement, adding ACF to both, we get the result, right?